Hello and welcome to Python for Engineers. This is Lesson 2, Installing Anaconda. Our agenda today is going to be very short. We're going to review how to install Anaconda, and then we're just going to do some basic computations to make sure that Anaconda works. The reason I chose Anaconda is because it's designed for numerical computing. Also, it comes packaged with Spider and Jupyter Notebook, which are both great IDEs. Particularly Spider. I'm going to go ahead and launch Spider right now just to show you that its interface is very similar to R or MATLAB. So like many engineers, if you're coming off of those software packages, you'll be very comfortable using it. Some alternatives that also provide a nice IDE that is similar to things like R or MATLAB, or RStudio, are PyCharm, which is very, very popular. It's a little bit more heavy duty than Spider, but it does provide some functionality as far as creating packages, which is very useful as you build your skill set as a developer. There's also Rodeo, which is as you can see by the screenshot, is very, very similar to RStudio or even MATLAB. You've got the area in the upper left where you're writing your code, and then right below it you have a console. To the right of that, in the second quadrant, you've got some visual stuff, and then right above that, in the first quadrant, you've got your variable explorer, which is obviously very useful. And this is what Spider is like. We can write code over on the left. That's where our currently active Python module is. To the right, we've got our variable explorer, file explorer, and even a little help window, and our console over also on the right, but lower. Anyways, let's go ahead and install Anaconda. The best way to do that is to Google Python Anaconda, and that will take you to anaconda.com. From there, you can just click download for Windows. A quick note, I will be using Windows packages. I will be developing in Windows. Some purists might not agree with that and insist I use Linux. Linux is very good. It's incredibly powerful. It also has a little bit of a steeper learning curve. And as engineers, we really aren't interested in tweaking every little thing about our operating system. We just want to hit the ground running and do some great science. And Windows is good enough for that. If you want to do some more advanced stuff like compiling TensorFlow from source, which is very useful for distributed computing stuff, you definitely want to use Linux. But for now, we're just going to stick with Anaconda, and we're going to stick with Windows. So you just go ahead and click this. It'll take you down here. You want to use Python 3.7. That's the most up-to-date Python. Python 2.7, it's useful for some backwards compatibility, but support for Python 2 is going to end in a few years. You don't want to be writing code. You don't want to be pushing packages out in Python 2.7. It's bad praxis, So we're going to stick with Python 3.7. We're just going to hit download. You can hit, these are just graphical installers, but if you hit download, it will ask you some stuff. This is just marketing stuff. But as you can see, we've already started downloading it here. I'm going to go ahead and cancel the download. Installing it is just like installing any other software in Windows. Just double click this file and follow the prompts. But once you do install it, you'll get a window similar to this. Let's go ahead and explore the Anaconda Navigator window. So if you'd like, you can look at documentation and the blog, and you can even give feedback to Anaconda, and they will listen and incorporate that. Over on the left, we also have the community tab, or the community pane, which lets us see what's going on in the Python community. For example, it'll give you news. For example, PyCon Cleveland 2019 is coming up in May, and you can read about that. This will update whenever you connect to Anaconda and connect it to the internet. It's also got forums, right? You can jump right to Stack Overflow. You can jump to Bokeh forums and get some help on things that you might need. It's also got a learning tab, so you can go right through Python tutorials. it's nice and self-contained, and it comes with packages. This is another reason why I like Anaconda, is because it comes with packages designed for STEM professionals. For example, it comes with NumPy, it comes with Matplotlib and SciPy. So that's the Anaconda Navigator window. Eventually, you're going to want to play around with environments, but this environments tab lets you see what packages you have installed. I'm going to stick with my boring old base environment. This is useful if you remind me later. This is useful. It's useful to create new environments if you want to play around with like development releases of different packages. Now let's go to the home window. And as you can see, we've got Jupyter Lab, we've got Jupyter Notebooks, and we've got Spider. I'm going to show you Jupyter because you should definitely get familiar with it, and we will be using it later. And I've already got Spider launched. So once you launch Jupyter, you actually get a, so these aren't Python files, they're Jupyter files, they're Python notebooks, and they look something like this. What you've got is like a block of code, and you can just insert blocks of code, and it's really cool. It's really useful for creating documented code. What I really like is that any block can be changed, cell type, into markdown. So that way you can say this is a markdown cell. You can just type in whatever you want. I am talking about the code below. And then you can export it. Oh, I don't know why it's running so slow. But anyways, you can export it as a PDF or an HTML file and just push that out onto a website. It's super useful. Are you sure I want to leave? Yes, it's super useful, and you should definitely get familiar with using Jupyter Notebooks. But for now, we're going to focus on Spider. So once you have Anaconda installed and you spin Spider up, you'll get a window that looks similar to this. You want to make sure that you've got your console over here, and it's the IPython console, not the Python console. I know that's confusing, but just look for I before Python. And then you've got your window here where you can write code. So I'm going to save this as, let's see, testfile.py. And yeah, it should look something like this. What we're going to do, once we've started here, we're just going to do a quick gut check in the console and see if we've got some important packages. So we will try to import NumPy. And there shouldn't be any error, but if I do NumPy, then I got some information about the module and where it's located. That's one thing that you should know is the command where Python. This will tell you where Python is executed or is installed, so that if we want to, we can just, if we want to run from the command prompt, we can switch by following this path. So I want to do cd anaconda 3, and then I can do python.exe, and boom, I've got Python here. Okay, so a few things about this. I'm going to show you the variable explorer, which should be something you recognize from MATLAB, for example. And let's see, I'm going to assign a variable a to 3, and it shows up in my variable explorer as an int. If I say b is equal to 3.1, it shows up as a float. You know, these are just different types and all that. Let's see, I'm going to say c equals a plus b. Oops, a plus b. And boom, here's another one. So this is one thing I love about Python, is that it'll translate types as necessary, right? In some languages, you can't just add an int and a float naturally. It messes up. One thing I also like is that it'll change types as needed. So 3 divided by 6, these are ints, right? But it'll give us the float answer. So I'm going to say d is equal to 3 over 6. Oh, here we go. A equals 3, b equals 6. And c equals 3 over 6. So we see that a is now the int 3, b is the int 6, but c automatically gets converted to a float. That's one of my favorite things about Python, is you don't have to worry so much about types. Let's see. There's a few options I want to set. So if we go up top to Preferences, in the Tools window, I want to make sure that our, here we go, graphics. When you go to graphics in the IPython console, under the graphics option, it's probably going to say the backend is inline. I like to change that because I prefer my plots to pop up. So the reason I like to change from inline graphics to basically anything else is because when you plot things, it'll come up in its own figure window. This is good if you want to do a little interaction. You know, you can zoom in to a rectangle, you can pan, and let's see, there's a few other options. You can configure the subplot. Ooh, you can change the borders, the spacing, all that stuff, and then you can save it also, so you can save it as a PNG and, you know, throw that in whatever presentation you're putting together. That's a little bit harder when it's inline. Again, this is just for interactive stuff. We will be going over how to make plots and save them programmatically. Okay, so the big things we covered are why Anaconda is good, how to install Anaconda, and a few options to set just to make Spider play a little nicely. Just remember, when you start Anaconda, you're going to want to go into Spider, and that's going to be your IDE. Oh, I guess I want to cover some very basic math.